So hey guys, welcome back to another lecture, full machine learning course. So in our previous lecture, we have discussed some of the types of the 12 types of matrices. I hope you have a better understanding these 12 matrices. And after that, we're going to cover some of the most amazing topics in the matrices. So we're going to cover something known as determinant. So we're going to cover something known as determinant. So what do you mean by determinant, and so how it is useful in machine learning, and why we have to learn this determinant? So let's look at that. This mainly comes in the machine learning as well as deep learning as well. So this determinant comes in the machine learning and the deep learning as well. So it is used in solving the linear equations. So as I said in a previous lecture, so what is linear equations and all of that, just preview that, you will get a good idea. Or just ask the Google, bro. Just ask the Google and you will get a tons of examples and etc. And so it is useful in solving the linear equations. So it helps you to know the linear transformation change their area and volume. So it helps to know like how the linear transformation is changing their area and the volume. So I have discussed the linear transformation in the previous lecture. Just see that. So how the transformation, so just remember this, like they are transforming the values. So just remember like this, there is some kind of transformation out there from one point to the another point, from n dimensional to the m dimensional. So it helps to know. So what we are knowing, like it helps to know like how the what we are knowing, like how the transformation changes their area and the volume. So I will give you example, then you will get a better understanding. So as of now, by telling you won't understanding nothing, so I'll give you an example, then you have a better understanding. Like, so we are taking a determinant, bro. So we have taken a determinant and the resulting must be this, just leave it a. So we have taken a determinant of a. So we have taken a matrices over there, this which is 5 2 4 3. We have taken that, and then we have a some kind of we cannot say this is a formula, but this is a method. This is a method, like we simply multiply a into d. We simply multiply a into d, and then we simply multiply c into b, and then we subtract from this to this to this. So I'll give you example, like, so the 5 is multiplied with the 3, and the 2 is multiplied with the 4. The 2 is multiplied with the 4, and then the resulting must be a scalar. So the determinant of any matrix, the resulting must be a scalar, means a value. So as I said, the scalar is just nothing but a value. Okay, so the determinant of a, the value is 7 over here. So we can do not only in a 2 into 2 matrices, so we can do in a 3 into 3 matrices. So what is 3 into 3 matrices? What if we do, how we can find the determinant in the 3 into 3 matrices? So it's just a bit of complex, but I'll try my best to explain it as simple as I can. So if we are taking a, and then we close these two, and we take this as a part. And then if we taking b, and then we close these two, and we take this part, d of gi. And then we are taking c, and then we close these two, and we are taking this part. We taking this part. This part. So just after that, after taking this, and then we have a simply like 2 into 2 matrices, like we simply multiply with these two, and then we simply subtract this, and then we simply subtract this, like e into I minus h into f, d into I minus g into f, and d into h minus g into e. So, and whatever it may be, the calculation might be, but the resulting answer will become a resulting determinant will become a scalar. That's it. So I will give you a practical example over here. So I'm giving a practical example over here. So we are taking a determinant of a. So we have a matrices. Over there. Then we have a 1 2 3 4 5 6 and 7 8 9 over here. So we just simply we so first we start from the 1, and then we close these two, and we just simply write 5 6 7 8 over here. I hope you're getting it. And then we after completing 1, we come to the 2, and then we simply close these two, we write the 4 6 and 7 8 9 7 9 over here. So after that we going to come with the 3, and then we simply close these two, and we going to write over here. So after that, as I said, in a 2 into 2 matrices, like we just simply multiply these two with the other two, and then we have a multiplication out there when we have this, and the resulting is 0. So here we have the scalar is 0, so determinant of a is 0. It is the output. The scalar is the output. So check the calculation, like how I have done this, so you can try it out on your own, like the changing the values and then etc. So why we use the determinant? As I said, it is used in machine learning and deep learning. So the determinant is used in a dimensionality reduction. So what do you mean by a dimensionality reduction? We're going to cover in the machine learning lectures, when we cover the machine learning lectures in the introduction, and I'm going to cover. So just as simply I will tell the dimensionality means we have a dimensions like 2 into 2 and 3 into 3. In the further lectures, like we have a problem with these dimensions, like we cannot solve with the dimensions, like so we reduce them. So there we are reducing, like here how we calculate these, like so we are reducing these two, and then we reducing into simple kind of things, and then we simply calculate the scalar, we simply calculate the determinant over here. So just as simple as that only. We do some with the help of those libraries, and it just can be done in a fraction of seconds. That's it. So determinant of ABCD is the area of a parallelogram in the diagram. So like I'll give you an example. Like we have taken a parallelogram. This, it is not a square. So some students think like it's a square. So the square is not equal. So just leave it, like I have written it wrong. But here the side, the length of these are not equal. It's just a kind of parallelogram. Just imagine like it a parallelogram. Okay. And then if we take these determinant or the area of parallelogram, and we're going to get something as scalar. So the determinant of these area, the determinant of these ABCD is the area of the parallelogram. Is the area of the parallelogram. I hope you are understanding. Like it calculates the area of that parallelogram. So we have properties out there. So we have properties like if the identity matrices. So what is identity matrix? So what do you mean by the identity matrices? So I just give example in a brief that you will get understanding. So if the identity matrices, then the determinant is equal to 1. So like identity matrices means like this, bro, having a diagonal 1 1. So this is called as a identity matrices. We're going to cover maybe in our next lecture, I think so. Yes. So we simply multiply these two and these two. 1 into 1 is equal to 1, and 0 into is equal to 0, and the answer is always 1. So if it may be like this, and the resulting answer is also 1, because it is identity matrix. So if we calculate these determinant, the answer is always 1. So after that, so if the rows are same, then the determinant is equal to 0. So if the rows are same, like AB and AB, so if we simply calculate cross multiplication, right? So AB minus AB, and then we simply cancel it out, and the answer is 0. So I have given a practical example also, like I have taken 1 2, and then we simply multiply these 1.1 into 2, 1 into 2, and the answer is 2 minus 2, and the answer is 0. You getting it? So if the values of the rows are same, if the values are rows of them, then the Answer is 0. So like if there is a r out there, so if there is a r out there, we simply take it, bring it out. If we think we simply bring it out, then we have a, then we simply write it as a matrices. So and then we have something known as the rule of Sarrus. So I hope you till now I hope you understanding like, so what is determinant, so why it is used in machine learning, and how it is used in the dimensionality reduction, and how we find this, how we find like a, how we find the determinant of the matrices in a 2 into 2 and in a 3 into 3 matrices. And then we have some kind of properties out there like how it is useful in identity matrices, and how the, if the rows are same, and etc. So after that we're going to cover something known as the rule of Sarrus. So what do you mean by like a rule of Sarrus? It's just a kind of a word name, and just kind of a new name like the rule of Sarrus. It's just simple, bro, but the diagram shows like a complex kind of thing, but it's just a simple kind of stuff. So we have a matrix out there, we have a 3 into 3 matrices like 1 2 3 4 5 6 and 7 8 9. We have a matrices, and then we simply take, maybe I might take another two columns, taking two columns as a product. So I can take, I have taken an example like these two, you can take last two, or this one, these two, or we, you can take any kind of stuff, bro. So just try it out, taking these two, this and this, and taking out this one and the three also. Just try it out on your own, and you will get a hands-on experience, like you will get a better understanding by doing things out there. So we just multiply these two, like we have this also, I just forgot, like, so I'll keep it like, so we just multiply these two also, we just, yes, so we just multiply. Okay, understand. So we just multiply these lines, these green and red lines. We just multiply like 1 into 5 into 9, and a 2 into 6 into 7, and 3 into 4 into 8. Here also 7 into 5 into 3, 8 into 6 into 1, and then 9 into 4 into 1. So we just simply multiply it there, and the resulting, so whatever it may be, it will become a scalar. It will become a scalar. So just do one favor for me, like just do the calculations of this. It's just a matter of 10 seconds, I think so. And then find the answer, so what is the answer, just comment down below, so that I could know, like, so my students are following the lecture, my students are following the lecture. Yes. So then, and next it's going to be a next level. So what is this? So are you really excited for that? So thank you for making this much, for like having a 6 lectures, so having a 6 lecture out there. So by thank you for seeing my videos, like, so I hope you enjoy. So just comment down below, like, so what I have to improve, like, just comment down below. I definitely learn. I'm giving like a 200% to this course, like doing like anything more than anything, like, so this is my, as I said, like, this is my new year resolution, like, so I learn while teaching, bro. So I didn't expect a single rupee from this channel. It's just completely free, as I said na. It's just completely for the students who want to change their lives, coming from an arts background, and then teaching the ML. So you can understand like how far I came, like, so there might be a people, like from a non-technical background, and they want to study the ML and AI, but they can't study, like, even they can't get into a seat also in a university, like they just check the background, like they didn't get it the seat also. So the same problem with me, but I just made it, like, so I hope you also do it. So just take it as a new resolution, just completing this course with 150% of this, just give 150% of this, and just learn the outsources, learn by asking questions, not getting the answers. So one of the best way to learn in 2023, to ask questions, not the answers. So I hope you understanding, like, so we have to develop the child mentality, like the children learns by asking questions, right? So we have Google out there, we have Chat GPT, we have a chat gpt out there, we have many things coming out, machine learning, advanced machine learning and AI technologies. So we have a great future ahead, bro. So don't think like, if you are not getting, it's just a basic, bro. It's just a basic, like, it's just a basic. If you can't get also, we have a libraries out there, we have several libraries out there. If we didn't get, just leave it. We're going to get in our libraries. Like, if you don't know the multiplication also, the libraries are there. They do our work in a just a fraction of seconds. So don't worry about that, if you are getting or not. Just have a patience. So just have a patience. You just have a patience and have a hard work. So do it heartfully. Do it heartfully, then you're definitely going to get. So in this lecture, so just leave it that. So in this lecture we have discussed what is determinant, and we have discussed the properties out there, and we have discussed the rule of Sarrus and how these applied, then as how these calculated, etc. So we're going to cover in our next lecture something known as cofactor, minor, adjugate and inverse, and how these. So I'll explain this diagram, this whole diagram, in a simple manner, that how they are correlated to each other. Like, we cannot find minor without these, or we cannot find adjugant without these, like, etc. So I will explain each and everything. After that we're going to cover the minor of the matrices, adjugate, inverse and etc. So I hope you enjoy these lectures. If you like the lecture, so please share with your friends and like this session. So I hope you'll enjoy this lecture. So until then, bye bye, see you guys in our next lecture.